Okay, so here we are now in Unit 7, Drugs and Toxicology. A fairly short unit in the text, but definitely a unit we could spend a lot of time on. As we've mentioned before, drugs are the largest volume of physical evidence and the major backlog for most of the state crime labs. So let's go ahead and see just what is going on here with drugs and toxicology. Toxicology is a term we've used before. Way back at the beginning of the course, we talked about Matthew Orfila, the father of forensic toxicology. Hopefully the term is familiar, but again, if we want to define it, it's the study of natural and synthetic drugs and poisons and their effects on the body. So a forensic toxicologist would deal with toxins found in accidental, homicidal, and suicidal poisonings, as well as drug overdose. So we've often heard, especially with high-profile celebrity type deaths, that we're awaiting the tox screen, right? The toxicology report that would indicate if there were drugs or poisons in the person's body fluids at the time they died. So to follow up, a forensic toxicologist, again, we already mentioned some of their responsibilities. It's both a scientist and a medical professional. So usually we're dealing with an MD, perhaps an MD PhD, someone who has the PhD in toxicology and a medical doctorate as well. The person's charged with detecting and identifying drugs and toxins in body fluids of the victim. They would investigate a death, poisoning, or a drug abuse death. So they would see not only if there were those illicit substances or poisons present, but also the level of toxicity and see if that was enough to kill the victim. So just because a person might test positive for cocaine or opiates or something that's a substance that may have been by prescription or may have been illegal, then we need to know, were those levels sufficient to kill that victim? The way we tend to make those determinations are by something called the lethal dose, or LD50. The LD50 is the ratio between the mass of the toxin and 1 kilogram of the body mass, so it's usually reported in milligrams per kilogram, and again that 50 means that about 50% of the time that dose would be expected to be lethal. So half of the population would die with that dose, the other half may survive, but again, it's a fairly lethal dose, and it's something that we would tend to consider to be sufficient to kill our victim. The smaller that LD50 value is, so the smaller the number of milligrams of the substance per kilogram of body mass, the much more dangerous that substance is. So if something has an LD50 of 1 milligram, then that's a far more dangerous substance than something that has an LD50 of, say, 100 grams. As the text mentions, it's really a situation where the dose makes the poison. Anything's deadly in really large amounts. What we're looking at here with the drugs and poisons are substances that could be toxic in smaller amounts. All right, so if that's what the toxicologist does, then let's look at how they collect and preserve that toxicological evidence to perform those analyses. So the medical examiner or the coroner would typically collect these specimens during an autopsy, so if we're dealing with a post-mortem investigation, or they could do it in vivo, meaning in the living body if the victim or the suspect is alive. And so we'd be looking at body fluids there that could include blood. Urine would be preferable to test someone who's still living, but even in a situation where the person's died and there's still urine in the bladder, that could be tested. Stomach chyme would be another fluid that could be tested if the person's ingested, say, a drug in pill form, and then it may not be fully digested. It could still be present in the stomach chyme and it hasn't been distributed to the body yet. So those are some places and ways to look for the different drugs or poisons or toxins. So once you identify your specimen, then those specimens can be packaged and sealed to prevent loss, to prevent cross-contamination, and just to make sure that it's a situation where we know that we've tested that particular body fluid for the poisons or toxins or drugs that we're investigating. If the specimen itself is volatile, like the glue that gets huffed or the gas from an aerosol can, first you make sure that you put that specimen in an airtight container to make sure that you don't lose that volatile specimen to evaporation. And of course, like in any investigation, we have the proper use of the chain of custody, particularly important here when we're talking about drugs, because drugs have street value, and we want to make sure that however much drug has been collected is the same amount of drug that is returned, aside from a very, very small amount of drug that might be used for testing. So this isn't so relevant for the drugs in the body fluids, but for the solid drugs that could be seized, then we have to be very careful that they're tracked and the chain of custody is intact in case large amounts of cocaine go missing, for instance. Another consideration, especially if the victim or suspect is still living, is that drugs will begin to dissipate from the bloodstream within 24 hours and within 72 hours for urine. So we do have those timelines to work against. So if you're not able to collect the sample from the living person within 24 hours or 72 hours in the case of urine, then it's best to test the hair for drugs. We talked about hair earlier in the course, and we know that it's formed by that very strong and long-lived protein keratin. So the keratin protein traps the drugs inside of it. The hair shaft becomes a marker. We talked previously about the idea that hair grows about 1 centimeter per month. So looking at where the hair marker is for the particular drug, it gives an idea of when that drug was abused. And that can be a very powerful way to test for drugs, much longer than 24 hours for the bloodstream or 72 hours for urine. Major drawback is the drugs could get into the hair from environmental exposure. So instead of the person ingesting the drug and it ending up in their hair, maybe the person had the environmental exposure to the drug through the hair, and that can be a major argument that the defense will make, and it is a drawback of using the hair method to test. So hopefully you're able to get that test within 24 hours for a blood test or within 72 hours for a urine test, so that you're not relying just on the hair method that could be controversial in a trial. All right, so far we've been talking about toxicology, where we're searching for the drugs or poisons or toxins in body fluids. Let's switch gears to looking at the drugs themselves that are likely powders. That's the most common way you're going to find these drugs. And what happens if we test those powders themselves? Well, in the field, the officer's going to use what's called a presumptory test, right? Most officers aren't chemists. And even if they are, they're not likely to have a full-scale drug lab in their squad car. So this is a quick and easy way to determine whether a sample is likely to be an illegal drug. So they're quick and easy. If you look at the image there, they're typically one or more ampules, which are these sealed glass vials, so that the reagents don't evaporate. They're typically solutions, water-based solutions, and they can be useful in the field to determine if a drug is likely present, but they're not allowed in court for convictions because there are false positives. So what will happen is the officer will put a small sample into the bag. They're usually these heavy thick plastic bags, and you can put the sample, which, as I said, is usually a powder, right into the bag. You don't need much of it, very small amount, especially since the charge is going to depend on amount. You don't want to take any more than you need to. So depending on the particular test used, you'll see for the two tests that we have there, we're looking for a change to blue in the top case after the powder is inserted and the ampule is broken. If it changes to blue, that's likely methamphetamine or MDMA, ecstasy as it's known. That would be a positive result. If it doesn't do that, then it's not likely to be either of those drugs, but it doesn't mean it's not an illicit drug. You could use a different test. As we see down below, there's a test for marijuana that would involve breaking one ampule, and it does matter which one, so there is an order and the directions tell you that. And if you break that ampule with the drug in, or the suspected drug in the baggie, then first you'll see that sort of magenta color change. Then when you break the next ampule, you'll see that you'll get a separation where you have more of a lavender top and a magenta bottom. That would be the sequence you would need to have a reasonable assumption that that is, in this case, marijuana. So the different drugs have their different tests. Again, officers get pretty knowledgeable about what's the most likely drug that's present based on what's popular in the area and based on the appearance of it. So that's how it works. So we have a number of different test results there. So the marquee test there, purple with heroin, morphine, and opium derivatives. It's an orange-brown with amphetamines and methamphetamines. There's the Dili-Kopiani test. That's violet, blue with barbiturates. The Duquesnoy-Levine test, purple with marijuana and chloroform. That's the one we see over on the left there. Notice it's E is the way that it's typically known as drug test E, since that's a mouthful. A lot of these names are mouthfuls. And the other two that we see, Van Erck is a blue-purple with LSD, and the Scott test makes that blue color with cocaine. So again, these have false positives, so they do need to be followed up with a confirmatory test if you get a positive presumptory test result. Speaking of confirmatory tests, a confirmatory test is used to prove which specific drug is present, if any. As I said, there are some false positives there that are chemically similar to the drugs and give a result like the illegal drug would, but they're not illegal substances, and therefore the suspect has a right to have that suspected drug tested to confirm that it's either the drug it's assumed to be or something that is not an illegal drug and would not warrant conviction for breaking a drug law. So the confirmatory tests are longer and more thorough. Again, these are what tend to be keeping technicians busy in crime labs and state crime labs throughout the country. The problem sometimes is that we have state crime lab technicians who see almost always a confirmatory test that supports the presumptory test, and because of the backlog and because of the high pressure and relatively low pay, they can be tempted. So we have a case that we'll look at later in the course, a woman in Massachusetts who just decided that she was done testing the substances. She signed off on all of them as confirmed to be the illegal drug, and again, that was an unfortunate thing because it deprived people of their rights, and her co-workers would complain that she was making incredible progress on her load, and they were struggling to keep up with the demands of their own load. And of course, the supervisor said, "You're jealous, you're just not as good a chemist," until finally the people were able to find someone who listened, and she was investigated and found to be doing these illegal activities. So like I said, we'll look at that. That's one of our last case studies. And the other confirmatory tests now that we'll talk about are just the ones listed in order, so I won't mention them by name here, but we'll talk about them in turn on the upcoming slides. The first confirmatory test we'll discuss is the microcrystalline test. So this test would identify a substance based on the color and shape of the crystals formed once it's mixed with specific reagents. So it's viewed under a polarized light microscope, and you see an image like the images we see on the screen. So the image on the left shows a positive microcrystalline test for cocaine. The image on the right shows a positive microcrystalline test for methamphetamine. So Again, these are very specific tests, highly specific tests for these substances with the reagents that they're combined with, and so nothing else should give that appearance that cocaine gives on the left or that methamphetamine gives on the right. So this is enough to say, yes, indeed, that substance that gave the positive field test, the color test, the presumptory test for, say, cocaine or methamphetamine is indeed cocaine or methamphetamine as evidenced by the microcrystalline test. A number of the remaining confirmatory tests rely on chromatography, and so chromatography, if we look at the actual meaning of the words from the Greek, is color writing. So if we look at the image on the left, the top or bottom images, hopefully these look familiar to you at some point in your education. I really hope that you had the chance to do paper chromatography. If not, you can set up a situation like you see on the bottom left image there, and just a strip of coffee filter is one cheap and easy way to do this sort of experiment. Get yourself a water-soluble marker, make a line just above the water level that you're going to dip it into, and you'll see that black water-soluble marker will separate into these beautiful colors. So I really hope if you haven't done this in person that you'll go ahead and take me up on that challenge, because it's amazing. Chromatography is really fun and quite cheap and easy to do. If you spend a few bucks on a water-soluble black marker, you'll have loads of fun along with a few strips of coffee filter. Again, you can see why the color that you get gives rise to this idea of chromatography, color writing for the name. It doesn't always involve visible colors. Paper chromatography could involve ultraviolet active substances, so you might not see anything under normal light, but when you shine a UV lamp, you might be able to see the traveling of the components of a mixture. Gas chromatography, typically you don't see anything but a computer readout, but still it's chromatography because it's a method of separation. High performance liquid chromatography, originally called high pressure liquid chromatography, is another of the chromatographic methods, again, that relies on the principles of an attraction for the mobile phase, which in this example is the water that's being drawn up through the pores of that chromatography paper or your coffee filter if you do that at home, as well as the stationary phase, the paper itself or the coffee filter itself. So these different components have some attraction to the solid, the filter material of the coffee filter or the chromatography paper, and also to the solvent, the substance going up, and in this case it's water being drawn up by capillary action. So if they like the water more, they travel up higher. If they like the chromatography paper more, they stay down lower. Now looking at gas chromatography, again, GC, chemists were abbreviating things long before it was cool to text in these abbreviations. So GC is the one that's most commonly used for drug analysis. So gas chromatography involves a sample that's typically, again, in the case of illegal drugs, it's typically a powder that gets dissolved into a solvent like methanol, and then as it's injected into that injection port, the sample injector there in our schematic, it's instantly heated by this furnace that's the column oven there in our picture, and it becomes a gas. So the way we can force it through onto the detector is by using an inert carrier gas. So we use helium in forensics because we can't risk the carrier gas reacting with the compound. The defense lawyers would love to argue that, in the instrument it made cocaine, but really it was just sugar that was injected in. So by having helium, which is totally inert, we don't have to worry about those arguments because there's no way that the helium would chemically react with whatever was in the sample. So that's the method. Again, in this case, instead of using water and filter paper, we used helium gases like the water that's carrying along the substance, and the column itself has the ability to separate based on size. So the lighter things are carried out first by the helium gas. The heavier components take longer to volatilize and be removed from the column. So that's how we get our separation, and the different patterns are the different components. Most street drugs are mixtures, so it's important that we separate them first and then analyze each of the components to find out what is actually present. Now, one of the drawbacks of the GC that we just discussed is that it does destroy the sample. You're not going to be getting that back. Again, it uses a very, very small amount, but if every milligram counts, because you're really at the threshold of a higher drug charge based on the amount, or if you're dealing with something like an explosive that you can't heat up in a gas chromatography setup, then high performance or high pressure liquid chromatography is your preferred method, because this can be performed at room temperature. It can be used to separate the samples, and then you could analyze them afterward. So we have in this case the same sort of idea. We have the sample injected into the instrument, and then there's a column that has a packing material similar to that chromatography paper or the coffee filter in our first example. So the substances are going to have some affinity for that column and some affinity for the solvent or solvent system that's used, and depending on whether they like the solvent more, they'll travel through faster. If they like the column a lot, they'll spend longer there, and it allows us to separate each component of the mixture. Now, because we can do all this at room temperature and we don't lose any sample, at least nothing appreciable, it's valuable for samples where we need every milligram, or if we just can't expose them to high heat like the explosives that we talked about. To follow up, once you've separated the substance, we'll talk about the infrared spectroscopy method next, which could be used to identify those components. Okay, so infrared spectroscopy uses infrared light. We often think of it as heat light, right? So that's the end of the spectrum. So it's not very high energy. It's not going to destroy molecules. It's just going to cause them to vibrate if they have a certain interaction with certain wavelengths of energy. So that's how we identify the components. So first we separate the mixture by HPLC, and then we can look at the different components by infrared spectroscopy, and that'll give us a fingerprint of the compound that comes off at a particular retention time of our HPLC analysis. So again, the drawback with IR is it does require really pure samples, so we have to be careful that we've really separated everything in that HPLC, which involves adjusting solvent system, adjusting retention time, making sure the column material is correct. But once you do that, you can have a readout that's called a spectrum, and that IR spectrum identifies without a doubt what particular substance you're dealing with, again, assuming it was a pure substance, and you've retained that substance. It's not destroyed. Again, the chromatography just separated it, and the IR is just allowing it to interact with some low energy electromagnetic radiation to cause a vibration in the bond, and then it relaxes back to the normal state. Now, the last technique we're going to talk about is probably the most used. Again, it's because it's combined typically with the GC. So gas chromatography that we mentioned before is really a separation technique. It doesn't give us the identity, although we can make reasonable assumptions based on where in a GC pattern we get components coming off. Still, to confirm their identity, we should have the GC feed into a mass spec, so that the GC unit separates and then the mass spec analyzes the different components. This is a different scenario because the mass spec is destructive. The way that it works is by breaking that compound into smaller pieces that we call fragments. So we've used, again, enough energy to break down the original molecule into smaller pieces. The computer can calculate based on that pattern of pieces that we get what the original molecule must have been. It's very, very sensitive. It can tell the difference between cocaine hydrochloride, which is the cocaine that's typically snorted, very expensive cocaine for businessmen and women and actors and people with lots of disposable income, as opposed to crack cocaine, which is the free base, which again, they just vary by an HCl molecule, but it's that sensitive. Just like for IR, which is another identification technique, another way to get a fingerprint, we call the readout a spectrum. So you can have an IR spectrum if you used infrared spectroscopy, which we just discussed, which again was useful for identifying drugs if they're in pure form or explosives that you've purified by HPLC. But if you can deal with a substance that can tolerate the heat of a GC, then following up with mass spec is the easiest and most common method. GC mass spec is without a doubt the most common way to confirm a suspected drug because it's likely a mixture, and this method of GC coupled with mass spec gives you the identity of the components of that mixture. Okay, so hopefully you enjoyed that crash course in analytical techniques, because now we're going to move into our discussion of the drugs themselves. All right, moving on to discussion of the drugs themselves, we'll start with the most commonly abused drug, and that is alcohol. So again, it's a tricky one because alcohol is legal for some, not legal for others. But the reason we tend to care most about alcohol is because of what it does to judgment and reaction time and things like that. So drinking and driving is really the concern with alcohol, and that's what we're going to address here. BAC, blood alcohol content, which is determined by GC if we're talking about actually taking the blood and analyzing it, but we can get a reasonable determination of BAC by a method like the breathalyzer, which doesn't actually use the blood but relates the breath volume of alcohol to a blood alcohol content through some fairly straightforward math, but something that we're not going to get too into here. So DWI is the charge for driving while intoxicated, 0.08 BAC or higher in New York State for the DWI. DWAI, driving while ability impaired, has a BAC of 0.05 to 0.07. So it's not a DWI at those levels, but it is still an offense known as driving while ability impaired. DUI would be driving while under the influence of these other drugs that we'll talk about. So alcohol would be the one that we talk about with DWI or DWAI, but if you're under the influence of another substance, marijuana or cocaine or something else that could impair your ability to operate a motor vehicle, then DUI is a charge that you could face. Implied consent, many states like New York will have someone operating motor vehicle having implied their consent, meaning that if you operate a motor vehicle in that state, then you have given consent to the test. Now, of course, you can still refuse the test. We'll talk about that, but it typically means that refusing the test is going to result in bringing you into the station and observing you and that sort of thing. So just realize that by operating a vehicle in certain places, you've already implied your consent to a field sobriety test or another type of test. For those of you who are a little younger, you've probably lived your whole life under the New York State zero tolerance law. Some of us who are a little older may have been born before the law went into effect back on November 1st, 1996. But again, it applies to a person under age 21, which is, again, the legal age for drinking in New York State, who operates a motor vehicle with a BAC of 0.02%, but not more than 0.07, because once you're up to 0.08, again, it's a DWI regardless of your age. So zero tolerance law, of course, is a misnomer because you see there is some tolerance. We don't bother with BACs of 0.01, for instance. Well, that's because certain cough syrups, mouthwashes contain alcohol, so you certainly don't want to use mouthwash right before you take a breathalyzer. That's going to give a falsely high value if the mouthwash contains alcohol. So just be careful. You don't want to impress the officer with that fresh breath. That's going to make you look like you're well beyond the legal limit because your breath amount of alcohol will be outrageously high compared to what's actually in your blood. Another reason why we do allow some alcohol present even in underage individuals is that it might be, a permissible part of a religious ritual, like, for instance, Roman Catholics that would consume a small amount of wine as part of their celebration. The idea of a Jewish family allowing a member to have some wine at the Seder meal, even if they're below the age of 21. These sorts of things. Again, you're not allowed to get drunk because you're at a graduation party for a family member and you're 17 years old, but if there's a small amount of alcohol consumed as part of one of these religious or family celebrations, then it's generally accepted as long as you retain that BAC of less than 0.02 for compliance with the zero tolerance law. So what happens if you're not compliant with the zero tolerance law? Well, if you're under age 21 and you have a BAC of 0.02% but not more than 0.05%, then the offense you're in violation of is driving after having consumed alcohol, which is a zero tolerance violation. It's generally an administrative hearing, again, not usually too severe of consequences, but something that shouldn't be taken lightly either. Once you hit that 0.05% up to just under 0.08%, now it's driving while ability is impaired, and again, that's going to land you in criminal court. 0.08 or more, as we said, is driving while intoxicated for anybody, and that's also going to lead you to criminal court and lots of expensive legal fees, and insurance is going to go up through the roof, and it's something that you just don't want to deal with. So hopefully you make the right choices beforehand. If you're underage, you don't consume alcohol. If you're of legal age, you make sure to have arrangements if you're going to be consuming alcohol in quantities that could land you in trouble. Have a rideshare program or a designated driver or anything that's going to help you make the right choices, because once you start drinking, as we'll talk about, your judgment gets impaired, so you have to have your plan in advance. Now, all alcohol is not equal when it comes to the impact on blood alcohol content. So we, could enjoy a small amount of alcohol if we're of age, and, if we're just going to have a glass of wine or a bottle of beer with dinner, that may be totally acceptable. It might increase your blood alcohol content slightly, but not to a concerning level. So what we need to keep in mind is that the rate of alcohol absorption can be affected by these four factors. So first of all, how much alcohol is consumed and how fast it's absorbed. So the more that you consume, the faster it's absorbed, and again, the more likely you are to enter into that driving while ability impaired or driving while intoxicated level. So if you're just going to enjoy a small amount, then realize that mixed drink with 80 proof liquor like vodka or gin, for instance, is going to have as much alcohol as a 12-ounce serving of beer or wine cooler or a 5-ounce glass of wine. So just realize that the quantity of alcohol is going to vary based on the particulars of the drink. Okay, wine's going to have a higher blood or a higher alcohol content than beer, for instance, and the 80 proof vodka there is going to have a higher alcohol content than either of those. So keep that in mind as you're considering the quantity of alcohol consumed. Another factor is time. If you're, taking shot after shot of vodka, then that's going to enter into the blood much faster than if you're nursing a beer over a 2-hour dinner. So how long it takes for you to consume that alcohol is a consideration. The form of alcohol, again, we've already danced around this a little bit, but if you have vodka, which tends to have a fairly high alcohol content compared with beer, which has a relatively low alcohol content, that's going to make a huge difference if you're consuming the same quantity of vodka and beer in terms of the impact on your blood alcohol content. Finally, stomach contents. If you're having that wine or beer with dinner, that's going to affect the blood BAC a lot less than if you're drinking on an empty stomach. Again, those free peanuts don't count. Those are just there for the salty factor to make you drink more. We're talking about a substantial amount of food, not just a few handfuls of nuts or popcorn or something like that. We're talking about a full meal. That additional food in the stomach is going to slow the absorption of the alcohol. Now, looking at those factors, let's see how we could get an actual mathematical percent BAC from taking those different things into effect. So our equation up at the top, percent BAC equals 0.10 times the mass of alcohol divided by the product of the volume of distribution times the body mass for the individual. So if we look, the mass of alcohol is going to depend on how that alcohol is reported. So we have proof and we have percent. Proof is an older method, but it's still fairly commonly used in the United States. Percent is, again, a little more obvious. It's the volume per volume percent of alcohol in the volume of the drink. So if you're using proof, when we looked at our previous example, we had 80 proof vodka. Well, the proof is really just double the percent. So that's why we use 0.11 if we're dealing with proof, because proof's already double. We use 0.23 because it's really 0.114 or whatever. And so when you double it, it's 0.228 and it rounds to 0.23 because the percent is half the proof. So that's why those values differ. So be careful if you're performing this calculation. Make sure you're paying careful attention to whether the alcohol amount is reported in proof or percent. But either way, you'll take the ounces of the liquor times the proof if the proof is what's reported, or times the percent if the percent's what's reported, and just make sure you use the relevant value, 0.11 for proof or 0.23 for percent. Finally, nature's just different. So the volume of distribution is assumed to be 0.7 liters per kilogram for men, as opposed to 0.6 liters per kilogram for women. So just biologically, men process alcohol differently than women, and so they have a little higher tolerance there before the same impact on BAC. Again, it's not anything discriminatory. That's just how it works. And our last factor is body mass in kilograms, right? We use kilograms here in forensic science because science uses the metric system and the kilogram as opposed to the pound. So since you're typically given body weight in pounds, you'll need to divide that by 2.2 pounds per kilogram to convert it into kilograms. So once you've made that conversion, you can go ahead and use our equation as written. So let's go ahead and try a couple of examples of this sort of calculation. All right, so our first example, we're going to be calculating the BAC of a 120-pound woman who consumes 3 drinks, each of which contains 1 shot of 80 proof vodka as the source of alcohol. What is her BAC? Now, as a reminder, 1 shot is equal to 1.5 ounce of vodka. So make sure you appropriately apply that equation from the previous slide. Percent BAC equals 0.10 times the mass of alcohol, which in this case we'll be using the 0.11 times the 4.5 ounces, 3 times 1.5 ounce for each of the drinks, times 80 proof. Divide that product by the product of a volume of distribution, which would be the 0.6 liters per kilogram for our female here, and then times the body mass in kilograms, so that 120 pounds should convert to roughly 54.55 kilograms. So go ahead and try that out and see what you get. Pause the video here while you do that work, and then when you pick it up, we'll check our answers. Okay, hopefully you got an answer of 0.12% BAC. So this woman is well beyond the legal limit, so hopefully she is not driving with this percent BAC. The other thing we should mention that our equation doesn't really account for is time. So this would be your percent BAC probably 1 to 2 hours after consuming the alcohol. It's not instant. In this case, if she was drinking these shots pretty quickly and she had nothing else in her stomach, it could be even sooner. But probably within an hour to two, we'd be looking at that 0.12% BAC. It would take 9 or 10 hours for her body to eliminate all that alcohol to the point where she'd be back down to a 0% BAC if she didn't consume any other alcohol. So again, sometimes people think that time is their friend. It can also be their enemy. If you walk right out of the bar, you're better off getting your breathalyzer test right then before the alcohol's had as much time to absorb. If it's been a few hours, then maybe playing the waiting game is in your favor, but hopefully you don't find yourself in either of those situations. Okay, let's try another one just to make sure, especially if you struggled with the last one. In this example, we have a 180-pound man who has 4 beers, 4% alcohol each, 12 ounces each. What is his BAC? And again, this would be probably an hour or so after consuming these that we'd calculate the BAC for. So make sure you go back to that equation, 0.10 times MA, the mass of alcohol. In this case, we're using percent. So the percent would mean that we'd be using that 0.23 times, in this case, a total of 48 ounces times our 4%, and then divide that by our volume of distribution. Since it's a male this time, we'd be dealing with the 0.7 liters per kilogram, and his body weight, 180 pounds, converted into a body mass in kilograms, should be roughly 81.82 kilograms. So go ahead, make sure you carefully apply the equation and pause the video here while you do the work, and then we'll compare results. All right, so this individual is right at the legal limit there for being charged with DWI, so the 0.08% BAC. So the calculation, again, is time dependent. So maybe this individual, because he's right at the limit, if he refused the breathalyzer, then by the time he gets to the hospital for a blood test, he may be below it, so it could work in his favor. But again, like we said, it's not worth playing the numbers game. It's better to just make sure you have a plan if you're going to be drinking more than one beer, let's say, that you've got something in mind as to how you're going to get home without driving. The value here, if you came up with a different value, either for the first example or for this example, please do reach out. Let me know if you need some help figuring out where you may have gone wrong. It could just be a calculator issue. These calculators, again, are finicky, and if you don't enter it in the right way, or you don't multiply that volume of distribution times the body mass before dividing the numerator by that, it can give you a very different result. So please do reach out if you're having trouble, but if you were able to answer both correctly, then you should be in good shape. All right, so now that we hopefully have a better understanding of the math behind the BAC calculation, let's take a look at how DWI is determined in the field. So the most common way that the DWI process starts is with an officer noting erratic automobile behavior or traffic violations by the driver. So depending on what happens when the officer pulls over the driver, it could likely lead to first one of the field sobriety tests. So these are the NHTSA field sobriety tests, and you'll notice the three most popular ones are the horizontal gaze nystagmus, the HGN, the walk and turn, WAT, and the one leg stand, OLS. Notice that we are not singing the alphabet here for any of these or counting backwards. Those just are, popular on the TV shows and movies, but they're not the most common approved NHTSA tests. So there's also alcohol sniffing devices that can be used, but the field sobriety test would be more popular. Okay, so looking at that first one, the horizontal gaze nystagmus, here the officer would observe the eyes of the suspect. Can the eyes follow an object? Are the eyes jerking naturally? Are they jerking excessively? That sort of thing. So this can be useful not only for alcohol, but for other drugs. So if you were to administer the breathalyzer here, if the suspect's not under the influence of alcohol, but they are under the influence of an illegal drug that could result in a charge of DUI, driving under the influence, then this is a great test because it's not looking specifically for alcohol, it's just looking for the behavior of the individual and whether or not their eyes can follow an object normally. The walk and turn, again, would be useful not only for alcohol, but other drugs that could be present in the suspect's body. The suspect would take, in this case, we say 9 steps, but again, it's up to the officer to determine. It's going to be, more than 1 or 2 steps, but typically 9 would be a good number. So the suspect would put heel to toe along a straight line, turn on one foot, and then return in the opposite direction. So what you're looking for there is imbalance, which again, I don't know that I could pass this test sober because I don't have great balance myself. Hopefully the officer would understand. Looking for the wrong number of steps. Again, can't follow simple directions. Not turning. So if you've watched Cops or any of the reality type shows like that, you've probably seen that sometimes the suspects think that they're just going to take off, and since these would be suspects who likely are intoxicated or under the influence of other drugs, they're not going to outrun a police officer, and it makes for some chuckles on the TV program, but it's sad because, of course, it's a terrible exercise of bad judgment, and again, it's just unfortunate that the person's gotten themselves to that state. Finally, the other thing to look for is no heel to toe, so they're just trying to stagger by without doing the heel to toe. So if the suspect fails the test here, then it's on to either the breathalyzer or again, if it's another drug that's suspected, then maybe we'd be thinking about some of those color tests if there's a powder in the person's vehicle in plain view, for instance. Okay, and the last field sobriety test that we'll discuss here is the one leg stand. So another one that I'd have trouble passing sober. The foot is held 6 inches off the ground while the suspect counts aloud. The officer's looking for balance here, and again, I think the officer would probably understand if he or she's just dealing with an individual with terrible balance like myself. So there'd be, obviously the counting would be problematic if the person can't count normally, or if there's just other reason to believe that, they're failing this test more than based on just poor balance, that they're, under the influence of alcohol or other drugs. Now, the breathalyzer was introduced back in 1954, so it's been around quite a while. It measures alcohol content of the breath due to mixing with an alcohol-sensitive chemical. In the old days, it was a dichromate-based chemical test, which again is an environmentally toxic substance. It's bad for human health, so we've moved away from that, but that was the original system that was used. Because the alcohol amount in the breath is generally much less than in the person's blood, the instrument multiplies that breath value by 2100. So the bloodstream is 2100 times more concentrated than the person's breath. Now, if the person had used something like a mouthwash that we talked about before, then they're going to have a lot in their breath and not much at all in their blood. So that's something to be careful of. And again, that would be reason for the person to be retested after a little while. And if the test varies greatly, dramatically, because the alcohol was just falsely high due to the alcohol in the mouthwash, then that would be pretty obvious. For the original breathalyzer, and even for the modern one, you do have to be careful. Anything that the person's mouth contacts, you're probably going to have to change from time to time. And in its original form, there was no printout of information, so it was largely based on just trust of the officer. But nowadays, we have ways to see that the recorded value is kept and used for any legal proceedings that might be undertaken. All right, the breathalyzer today works by fuel cell, so it acts like a battery. The alcohol in the breath and the oxygen in the air combine and produce a very specific current from the fuel cell, so this is how we know it's alcohol, ethanol specifically, and not anything else. The amount of current is proportional to the concentration of alcohol in the breath, and here the results can be saved and printed, and certainly much more useful for court proceedings in that regard than the original form of the breathalyzer. So this is the more modern. That was the more traditional when we talked about the dichromate, but again, it's been around for decades now in one way or another, and it's useful for alcohol, but the field sobriety test that we mentioned could help to identify not just alcohol like the breathalyzer would, but other drugs that could impair function and create a danger on the road to others if a person's under the influence of either alcohol or other illegal drugs. Okay, now we mentioned earlier that New York State, and as well as a number of other states, are implied consent states. So just by operating a motor vehicle in the state, you've already given consent to a breathalyzer. However, of course, you can still refuse the breathalyzer, but there are some legal ramifications there. So first of all, you can still be charged with a DWI. The officer can, describe how you appeared at the scene, what your results were for the field sobriety test. The suspect could be taken and videotaped while in holding. And again, this is pretty damaging because the suspects usually act drunk, behave strangely, and it's, on video for the jury to see. If you later consent to a test, if you say, okay, yeah, let's go to the hospital and do a blood test, or there's a chemical test you could do at the station, that could play into the percent BAC because of the time factor. So if you're picked up right out of the bar, then alcohol that hasn't even been absorbed in your system yet at that state, if you were to take the breathalyzer, now will have time to be absorbed by the small intestine and raising the BAC. Of course, the opposite could happen. It could be that time allows you to lower your BAC a little bit, but it's a tricky thing to play, and especially if you really are quite drunk, then you're probably not thinking logically like that. The other thing that will happen, at least at the time this video is being recorded, is in New York State, refusal to take the breathalyzer results in an automatic $500 fine and 1 year suspension of your license. And that's a traffic infraction that's not changed even if you're found innocent of the DWI charge. So another reason to think about whether you really want to refuse that breathalyzer, or if you want to take the breathalyzer and get yourself a good defense attorney and try to fight the charge, especially if it's right near the legal limit and there's the uncertainty of the breathalyzer itself. That's certainly the better option in those situations than refusing the breathalyzer and dealing with those consequences. Okay, so now moving on from alcohol, our most commonly abused drug, to the other drugs that we could consider in this chapter. So, of course, the drug term itself comes from the German word Drug, which means to dry. So these were the herbal medicines used in the olden days before we had the pharmaceuticals as we know them today. So to dry those herbs and make them more potent, that's where we ultimately get our English word drug. In this context, drug refers to a substance intended for use in the diagnosis, cure, mitigation, treatment, or prevention of disease. So when we talk about controlled substances specifically, we're talking about a drug that needs a prescription from a physician. Again, just for the generic definition of drug today, it's something that causes physiological or psychological action in the body, but it's not needed by the body. So you may see, in certain pharmacies or grocery stores, there'll be things like melatonin, which is, at least according to the bottle, it helps to regulate sleep patterns. Well, melatonin is not a drug because it's naturally produced in the body. So it causes a physiological action, but it's already something that is produced and used by the body, so it's not considered a drug. A drug would be something foreign that the body doesn't produce, that does produce a response in the body. So a great example would be caffeine. Caffeine's a drug because it's not something that your body produces naturally, but it is something that causes a response to the body, and something that many out there probably feel like their body needs to get them going in the morning. So that's our little fine line distinction. Hopefully by defining the term, we have a better understanding of not only the generic drug, but also the term controlled substance, which we'll use throughout the rest of this lecture. Going a little deeper now, we'll look at the difference between illegal, controlled, and illicit drugs. So most illegal drugs are also controlled substances in the United States, and we'll talk about the different schedules for the controlled substances later on. Not all controlled substances are considered illegal, however, so just be careful. It doesn't go both ways there. All drugs, both legal and illegal, can be dangerous if misused, so that's why there are directions that indicate the proper use, and it's important that you read those. Finally, illicit drugs are those that have been classified as illegal because they pose a threat to one's health. And when we talk about the different schedules, we'll see Schedule 1 drugs are the ones that we consider them to have really no medical use and a high potential for abuse, and therefore we would list those as illicit drugs, as well as illegal drugs and controlled substances. So lots and lots of terms to keep in mind, right? So following up with that phrase, controlled substances, many controlled substances are abused. It's unfortunate, but that's just the way it is. Why is that the case? Well, because a lot of these will give a sense of euphoria. So, people have trouble dealing with reality, and not to belittle their difficult life. They're finding that release from the difficult circumstances of their lives by taking this controlled substance, getting that temporary sense of euphoria, good feelings, everything's fine. The problem is then they come back down, and the life that was already tough seems even tougher now because they've had that little break from it. They've had that bit of good feeling, and now normal feels even worse than it already was. So unfortunately, the answer for many of those individuals is to take more of the controlled substance. Well, the problem there is that tolerance increases. So eventually, not only do you need more of the drug to get the same effect, but you also become psychologically and physically dependent on the drug. Your body doesn't function well without the drug. So again, even what was your old normal, which certainly for many people is a really tough life, and I'm sure would be great to escape, but now that normal feels even worse than it ever did. So there's the tendency to abuse the drug, and not only do you need higher amounts, but you need it more frequently to obtain that same euphoria. So for those reasons, again, it's unfortunately fairly easy to understand how people get hooked on the controlled substance. Now, what about coming off of it? Well, that can have real consequences too. Certainly, you know, if it's our loved one, we would want to help them to get off of that drug, but you have to realize that there are withdrawal symptoms. If the person's again got that physical and psychological dependence, they're going to have withdrawal symptoms as they move off of that substance. So the psychological dependence means that when they no longer have that controlled substance, could lead to depression, anxiety, mood swings. The physical dependence can be even more violent. Again, cramping, vomiting, convulsions, hallucinations, insomnia, chills, all the way up to death. Certain drugs, if you've been a long-term abuser and you just quit cold turkey, ultimately the physical withdrawal symptoms can lead to death. So that's one reason why, for instance, heroin abusers might be given methadone to help get them off of that heroin without all of the negative physical withdrawal symptoms that, again, if they've been abusing for a long time in high amounts, could ultimately cause death if they just quit cold turkey on their own without medical supervision, that sort of thing. Now, we've already mentioned some drugs, but let's go ahead and talk about the general classifications of drugs. So we'll talk mainly about the narcotics, hallucinogens, depressants, and stimulants. We'll see that certain drugs will have activity that could qualify them within multiple categories here. We tend to go with a major category. The drug gets classified first by its major effect, and then again recognizing that it can have some of the other effects as well. So let's go ahead and take a look at each of these categories and give some examples of drugs that fall into each category as their major classification. So narcotics is probably the classification you're most familiar with, at least the term. And again, it's become sort of a catch-all for any illegal drug activity. So there's the narc is a term for someone who is a police officer who arrests people who violate drug laws, right? That sort of thing. So there's the narcotics unit. And that would refer to really narcotics specifically, but any drug by analogy. So when we talk about narcotics here in this forensic science course, we're looking at the specific meaning of something that is an analgesic, so it lessens or eliminates pain. Narcos is the Greek for sleep, right? The god of sleep. So it induces sleep, and that's, again, evidence of its depressive nature. So it lowers the blood pressure, it slows the pulse, it slows breathing, and you have to be careful because that's where overdoses come into effect, right? If you take too much of a narcotic, then the breathing can slow so much that the lungs aren't functioning enough to keep the blood oxygenated and the person could die. That's one of the major results of a narcotic overdose is death from asphyxiation, failure to breathe sufficiently. The major group for the narcotics would be the opiates, so derived from opium and the poppy plant. Heroin, morphine, codeine would be your examples. And again, heroin, of course, is a very big problem locally, nationally, internationally. You've also got the synthetic opiates, so they're not derived from opium, but they're able to mimic its effect. So oxycodone, which is used for chronic pain, and again has become something that's abused, so not used by the person for whom it was prescribed, but sold and used by others. Methadone, we talked about that already, used to wean addicts from heroin so that they don't suffer as severe of a withdrawal, both the psychological and the physical withdrawal symptoms, to help get them clean and make it easier for them to stay off of the heroin and rebuild their lives and hopefully not relapse to that drug addiction again. So the narcotics are probably the most well-known term, but again, it might be a phrase that's misused to mean any drug. Narcotics should fall into this classification because of their removal of pain and their causing of sleep specifically. Fortunately, our next category is pretty self-explanatory, right? Hallucinogens are those things that cause hallucinations. So they alter normal thought processes, they change our perception of the world, they generally improve mood, although not always. So if we look at marijuana, THC, tetrahydrocannabinol, is the active component. It's also a pain reliever. It helps with appetite, so cancer patients could sometimes gain benefits from using THC or some sort of synthetic analog to help their appetite. One of the drawbacks, of course, one of the many drawbacks of suffering from cancer is that you would often have very little appetite, not only from the cancer itself, but if you're taking anti-cancer drugs, those can lower appetite as well. So that's one of the potential benefits. Not only do you get more of an appetite, but you also don't feel as nauseous afterward. But again, its major classification is as a hallucinogen because it causes that altered reality. Psilocybin, mushrooms or shrooms, again, natural product that has been used in certain Native American ceremonies and things, but here we're talking about its abuse as a hallucinogen. LSD, lysergic acid, also known as just acid, that's a potent hallucinogen. Again, if we look back at the type of people that would use that hallucinogen, it tends to be your creative folks, the artists, the musicians. John Lennon, for instance, was a big proponent of LSD. The chemist Hoffman, who discovered it accidentally, detailed his own trips on it. If we go back to Lennon, though, his first wife, did not enjoy her trip. She had very negative trips, and it was one of the things that ultimately ended the marriage. Is that he was a proponent and an avid user, and she did not enjoy it, and it was one of the things that led to their breakdown. PCP, phencyclidine, this one is very scary hallucinogen. It was originally investigated as a pain reliever, right, as like a surgical anesthetic, and it works great to keep the patient from feeling pain, but it also separates their mind from their body. So you have this really scary situation where the person's superhuman in the sense of they feel no pain. You could shoot them, and again, if you shoot them in a non-fatal area, they can continue to walk right toward you. They can do some very gruesome things, and we have a case study that showed some of that. But it's disturbing, to say the least. Finally, there's some club drugs that tend to be much less disturbing than PCP, but they're more mild hallucinogens. So again, our classification for substances that primarily cause hallucination, but they can have other effects like marijuana, again, is a pain reliever, but we don't consider a narcotic because its more important effect is as a hallucinogen. Our third classification of drugs would be the depressants. These are also known as downers. They depress or slow the central nervous system. Alcohol is the most common example. It's also the most widely used and abused drug that we've mentioned before because it's present in great abundance and great variety, and it's legal for many people to enjoy here in the United States. So if we look at another group, the barbiturates, which are often anti-anxiety, anti-psychotic medications, they also have that depressant effect. They relax the user, they cause drowsiness or sleep. Again, they don't generally cause the analgesic effects of the narcotics, so depressants is the better classification for those. Some examples, diazepam, phenobarbital, some of the huffing substances, so the glues, cleaners, spray paints, aerosols that abusers will huff to get that high, the exhilaration, followed by drowsiness. Those are often examples of some depressants. So depressing, slowing down, as opposed to our next and last category, which will be the exact opposite. All right, so following our depressants with stimulants. So depressants were downers, so our stimulants are known as uppers, or speed is another one that's sometimes refers to a specific drug or just this whole class of stimulants. So they speed up the central nervous system, increase alertness, feelings of well-being, restlessness, loss of appetite. So the classic example is cocaine, which comes from the coca plant. Back in 1886, Coca-Cola had 60 milligrams of cocaine in each bottle. Nowadays, there's much smaller amounts, again, because chemists are so good at detecting really small amounts. You might be able to detect a little bit, but certainly not 60 milligrams like the old days. Since they use the leaves, again, you might have a very small amount, but not the levels that you had in the past, and certainly not anything that's going to cause much effect in a person's physiology. So cocaine, we tend to associate at least the cocaine hydrochloride with high-end users. Again, they'll snort it and that sort of thing. And one of the reasons they'll do that is so that they can be more productive, right? If they're businessmen or women or actors or whatever, they can keep up with their crazy schedule by getting that increase of energy from this stimulant effect. Methamphetamine is another example, so meth or crystal or crank, and we see in the far left the ice-like methamphetamine that's just known simply as ice as opposed to powdered methamphetamine. That is another substance that, again, with the opioid crisis, it's sort of going under the radar, but methamphetamine is still a terrible crisis in this country, and meth addicts have, not only terrible impacts on themselves, but if they're making the meth in meth labs, they can have greatly negative impacts on those around them. So as I just mentioned, meth labs are a very dangerous thing for all of us. It involves non-chemists, right, regardless of any fans of Breaking Bad out there. It's typically not trained chemists that are doing this sort of thing, but there's several fairly simple preps that even a non-chemist can follow. Most of the really easy preps use over-the-counter ephedrine or pseudoephedrine tablets, so that's one reason if anyone's tried to get those in the past several years, you've probably noticed you have to go to the pharmacist. They keep track. Typically by giving your license, that's how they would know. And if you're buying too many of those tablets in too short a time, then you're likely to get a visit from law enforcement to just make sure everything's okay. The reason why meth labs are bad news for everyone is because most of these preparations, first of all, they're not chemists doing it, so you're not guaranteed that it's going to be pure and void of any harmful side products. Even in a best case scenario, you're getting about 6 pounds of toxic waste for every pound of meth made. And of course, these are not people who are going to go and dispose of that waste in a responsible manner. So you can see instances where a mobile meth van could catch fire from the toxic byproducts of the meth synthesis. People are doing it in their apartments where there might be children nearby, even their own children in their own apartment or children in neighboring apartments. So it's really a public health concern and a very dangerous thing if someone's operating a meth lab in a location, especially one that's populated by other individuals, innocent children especially, that could be exposed to these toxic substances. So not only do we have the meth addict or the meth dealer to worry about, but also their impact on those around them. And so just to continue our meth rant here, we see some images of some female victims of meth abuse. So in the top left, we see 10 years of meth use and the impact that's had on this woman, again, who went from a fairly healthy looking woman to very sunken face, very thin because of the stimulant effect of the meth, and not eating properly. We don't see her showing her teeth, but probably like we see in the image to the right, very poor dentition. Usually meth addicts don't care about taking care of their body or their teeth, and they end up with very sad and very disturbing habits, like the teeth that are just gray or rotting, and from just not eating, not taking proper care of themselves. If we look down at the bottom, we see again at the bottom left, those could be burns on her face from the if she's smoking meth or whatever, but more likely, and the reason we see a lot of these women is they're picked up for other things, and one of the more popular things is to get their meth money is prostitution, and so they can be abused by their pimps or the johns or any of that again is part of their meth addiction, leads them into these dangerous situations. So that's why any of the illegal drugs, but in particular meth, is a very sad scenario for the abuser, for their family, for all the people hurt by that. So hopefully the individual can get some help and get clean, but it's a very difficult thing. Any of these addictions are difficult for the user and their loved ones. Okay, so moving on to club drugs. Again, these could have multiple classifications. A lot of them are probably going to be primarily hallucinogens, so they would stimulate that rave experience with euphoria, hallucinations, increased libido. Again, these are typically done in the club scene where you have that sort of party atmosphere. So MDMA, ecstasy, Molly, 3 different names for one thing. Again, that's a hallucinogen. Special K, ketamine, another one that would probably be primarily a hallucinogen. And those 2 would be abused intentionally generally in the club setting. Rohypnol is a very dangerous one because that's one that's not typically taken on purpose by the user. It's one that's slipped to the user. It causes amnesia. It's known as the date rape drug. And again, this is one to be very careful for because if you're at a club or a party where you're not getting the alcohol from the bartender, you should probably refuse it because you can't know that it hasn't been dosed with Rohypnol. You certainly don't want to find yourself in a situation where you wake up and don't remember what's happened to you or your body. So they do sell or I think it's even given away on college campuses. Certain colleges will provide students with, there's a nail polish that will change color in the presence of Rohypnol. So if you dip your finger with that nail polish into the cup, it could tell you if Rohypnol is present. Again, I don't think it's worth that. I think it's just safer to get the drink yourself. If you leave your drink unattended, then don't go back to it because you don't know what's happened to it while you've been away. And it's just a matter of keeping yourself safe in a world where there's some people looking to do you harm. And you don't know who to trust and who not to trust, especially a bunch of strangers at a party. So just take care of yourself and make sure that you don't allow yourself to fall victim to Rohypnol in particular by accepting drinks from people or leaving your drink unattended and returning to it. It's not worth the risk. The last group of drugs we'll talk about that doesn't really fit any of our classical categories would be the anabolic steroids. So these are substances that are chemically related to the male sex hormone testosterone, which we see there on our slide. They can cause users to develop those secondary male characteristics. We call those androgenic effects, and that's even females. Again, the females will, lose their more feminine features and become much more masculine in their characteristics. Accelerates muscle growth, which is typically why these things are abused. That's the anabolic effect. and so the illegal users are typically athletes looking to gain a competitive edge. So most sports will test for these, and again, I mean, baseball's been rocked by anabolic steroid abuse scandals. Golf, it's even been an issue in golf, which we don't normally think of as, you know, big bulky golfers, but still, to gain that little advantage, some of them have abused the anabolic steroids. It can be ingested in pill form, or it can be injected. Those are the typical ways that anabolic steroids are abused and gotten into the body, and they can have really serious side effects. Liver malfunction, certain cancers are more common in abusers, depression, unpredictable moods and personality changes. Again, there's some controversy over whether roid rage is real or not, but it seems like a number of studies have shown that these mood swings and personality changes are real effects of anabolic steroid abuse. So certainly, you know, an example of abusing a substance and with some dire consequences for those abusers. All right, so as we sort of wind down this lecture, we'll focus on the Controlled Substances Act of 1970. So that's the act that established the 5 categories, or schedules as they're more commonly known, of drugs based on their potential medical use and their potential for abuse. The U.S. Attorney General has the authority to add, delete, or reschedule a drug as needed. Again, because these schedules result in the need for a prescription to access most of these drugs, there's now the term controlled substances. You need a prescription to obtain them. When we get to Schedule 5, we'll see that a lot of those things can be obtained in smaller amounts over the counter. But by and large, if they're on the schedules, at least in certain levels, then they're going to need to be a prescription to obtain that drug. Okay, so our first one is Schedule 1, and these are the so-called nasties, right? These are the ones with no approved medical use, so they cannot be prescribed, a high potential for abuse. So heroin, strangely, marijuana is still on the list, at least the time of this recording. Even with certain states allowing medical and even recreational marijuana at the federal level, marijuana is still considered a Schedule 1 drug, which is unfortunate. It makes it more difficult to study marijuana because you have to, meet those federal guidelines if you're a lab that wants to investigate the effects of marijuana for, potential applications for. We already talked about the idea that marijuana can be helpful for cancer patients with improving appetite and decreasing nausea, but because it's still on Schedule 1, it's not been investigated nearly as much as it probably should for its potential benefits. LSD, MDMA, psilocybin, these are other examples of Schedule 1 drugs. So these are the most restricted because they have, at least according to the federal government, no medical use and therefore a high potential for abuse, and so they cannot be prescribed. Moving on to Schedule 2, now we have at least some accepted medical use, so these can be prescribed, but they still have a high potential for abuse, so they probably shouldn't be prescribed very often. Opium, morphine in particular tends to be prescribed for people who have severe pain and who probably will not be getting off the drug, so we don't have to worry about the withdrawal and the addiction that tends to go along with morphine. Morphine is a very powerful painkiller. Nothing else, at least at the moment, that works as well for people in severe pain, like stage 4 cancer patients who are not going to come off of the morphine, right? Their end of life is unfortunately very near, and so they will be taking morphine for the rest of their life. So it's about all we have to deal with that pain, and we don't have to worry in those cases, unfortunately, about withdrawal. Codeine is one that probably a number of you have had. It's often in prescription cough syrups. If you have a really raw cough, it does help with the pain. So even though it's a Schedule 2, it's actually fairly commonly prescribed, at least in that preparation. Most of the barbiturates are in Schedule 2. Cocaine's Schedule 2. Methamphetamine, believe it or not, can be prescribed as a diet drug, of all things. That's where it got its start. I don't know of any physicians that would be prescribing it. PCP, even more disturbing that one's still on the list of prescribable drugs, especially when something like marijuana is on Schedule 1 at the moment and PCP is on Schedule 2. It seems like things are a little backwards there, but that's the way the system is at the moment. Now moving on to Schedule 3, we're right in the middle here, so there's some accepted medical use, more medical use than Schedule 2, but still medium potential for abuse. So what we would find on this schedule would be some of the barbiturates, the ones that aren't on Schedule 2, would fall into Schedule 3. Anabolic steroids, again, we talked about their abuse with athletes, but they do have use, as hormone therapies and things like that. So they're still, again, medium potential for abuse, but medium accepted medical use as well. So that's why they're right in the middle of our schedules. All right, moving right along onto Schedule 4. Now we have even more accepted medical use and even lower potential for abuse. So here we have things like Valium. Again, there was a point, I'm not sure if it's still the case, but where the number of Valium prescriptions outnumbered the number of people in the United States. That's how common it was. That's because certain people were getting multiple prescriptions and then others were not getting any. I don't want to make it seem like everyone in the U.S. was on Valium, but you could certainly, at least in the old days, go to your physician and get a Valium if you were going to be taking a flight and you had some anxiety or having a medical procedure. They might give you a Valium to help decrease anxiety before the procedure. So it's historically very common. I'm not sure about these days, but Xanax, phenobarbital, Rohypnol. Again, Rohypnol, as we already discussed, has great potential for abuse in the club scene as a date rape drug. So that one is a little disturbing that it's on such a low schedule, because it does have that really unfortunate abuse to dose people, unsuspecting victims, with Rohypnol, and then have sexual abuse as a result of their inability to remember engaging in such activity. But it's on Schedule 4 for now, and again, the district attorney can reschedule these, but that's very rare that the Attorney General, rather, not District Attorney, I misspoke, but the Attorney General, typically, whether it's a Democratic or a Republican Attorney General in office, they tend not to do too much with the schedules. They've stayed largely the same as they did back in 1970. And finally, we have our Schedule 5, which is our greatest medical use, our lowest potential for abuse of all the schedules. And these are typically just higher concentrations of over-the-counter medicine. So ibuprofen and acetaminophen, which you could get over the counter at lower doses. These would be higher dosages that would be prescription only. So that's what we tend to see in the Schedule 5 drugs. So hopefully you've enjoyed our lecture on toxicology and drugs. And if you do have questions or concerns about any of it, please feel free to reach out to me. Shoot me an email and let me know what's causing you trouble, and hopefully we can figure out a solution. Otherwise, if things are going well, then that's wonderful, and I look forward to working with you again in the next unit. Take care, everybody.